Today we're going to learn a lesson about similar figures. What I like about this lesson is that we use this in everyday life, especially if you're in construction or architecture or anything like that. Okay? So the first thing we're going to talk about is what is the difference between a congruent figure and a similar figure? Does anybody know the difference? What do you think? What do y'all think?
I feel like the same.
What does congruent mean? Congruent means the exact same. Exactly, like a clone copy is congruent. So congruent shapes are equal measure. They have exactly the same shape. And the same size. They are the exact same thing. Like I said, it is a clone from one to the other. Now, congruent shapes can be flipped around and moved, and they're still the same. Similar shapes are not clones. Okay? Similar shapes, their angles are the same. So their angles are the same. What does the same mean? They're congruent. They're equal. But their side lengths are not. They are proportional. Now, I went years ago when I was up in Chicago, I went to the Museum of Science and Industry. And they have the coolest display there where they took downtown Chicago and they built models of downtown. What does that mean? They built replicas. What does that mean? They're the exact same thing, but they're smaller. They basically took the city and shrunk it, but it was all drawn to scale, meaning it was proportional. The buildings were the exact same measurement, just shrunk down. It was really, really cool display. You could kind of walk through the city and see it, but in a very small scale level where it was all in one giant room. Yes, it was super, super cool. They were the same shapes, but their angles were the same, but the sizes were not the same. Otherwise, we would just be replicating the whole city of Chicago, and you can't really do that. The sizes were proportional. Does that make sense? So it's basically where you take the shape and you shrink it, or you make it bigger, which is called enlarging it. Now, I have some pictures here to show you the difference between congruent and similar. Congruent, they took the square, they cloned it, it's the exact same square. This triangle is congruent, meaning it's the exact same thing, they just rotated it. Okay? Similar, everybody look at this rectangle. Does that rectangle look almost identical? Yes, everything is proportional to it. This side corresponds with that side. Yes? And this side corresponds with this side. Notice that their angles are what? They're the exact same. If you change the angles, then the shape changes. So their angles, this angle right here is a 90-degree angle. Therefore, this angle is also a 90-degree angle. So when you have similar figures, their angles have to stay congruent, but their side lengths are just proportional. Now, why do architects use this information? Think about what architects do before we build buildings.
They make them. They like lay out stuff.
They make what? I heard somebody. Blueprints. What does that mean? They make a scaled drawing, and they basically say for every square it represents a foot. And they have this scale that they use, and it is similar. It is proportional to what that construction person is going to build. Does this make sense? Okay. Why do we use similar figures in 7th grade math? We use them to solve for missing sides, and to do that we set up a box. Now, they don't like to use boxes on the STAR test. They like to use proportional ratios. So I am going to show you both ways, and you're going to see that they are the exact same thing. Make sense? All right, so look at this problem. This actually came from a 2016 STAR test. It says the two parallelograms, and then it tells you they are what? That means I know their angles are the same, and their side lengths are, but give me a better word. Proportional. Okay. It says, knowing that these are similar, and you can tell they look the same, yes, what would the length of PQ be? Well, here is PQ. If I don't know it, I call it X. Now, I love to teach this lesson with highlighters because I like to highlight what is called corresponding sides. So I want you to pick a color, and I am going to highlight this side, which is 12 inches, and I'm going to go to this shape, and I'm going to highlight the side that corresponds with it. So what side is it? 30. And then I'm going to take another color, and I'm going to highlight the side that I'm missing, and I'm going to highlight the corresponding side with it, which is this one. Now, the best part of this lesson is that there are multiple ways to write the ratio. I can do green over pink, and if I do green over pink, what do I have to do over here? Green over pink. What if I do green to green? Would that work? But then I have to do pink to pink. Now, if I do that, let's say I do green to green, if I put the smaller shape on top, then when I come down here, what do I have to do? Put the smaller shape on top. Proportions can be written a lot of different ways. But what I cannot do, are y'all listening? I cannot do green over pink and then pink over green. That won't work. I cannot do green over green with the small one on first and do pink over pink with the large one first. It won't work. It's no longer proportional. Are y'all with me? So the first thing I'm going to do is make a box to show y'all what it looks like. Y'all already know how to make a box. I'm going to do green to pink. Okay, what would my ratio be for green to pink? 12 to 16. All right, if I do green to pink, then I have to do green to pink over here, which would be 30 over X. How would I solve this? I could simplify first and then see if I see a pattern. And if I don't see a pattern, I cross, multiply, and then divide. Now I'm going to show you the way the STAR test would do it. They're going to make it look like this. And they're going to make you figure out what pattern they used and see if it's correct or not. So if they put 12 over 16 equals 30 over X, you would know they did green and green over pink and pink. Is this the exact same problem as the box? Yes or no? Could I cross, multiply, and divide? Could I simplify first? So what I need y'all to understand is if you're solving and you want to set up a box, it will always work. But in a minute, we're going to have a problem where it says which one is set up correctly, and they're going to give you a bunch of these. And you're going to have to figure out which one is set up correctly. To do that, you're going to make sure the colors are correct. And that it's small over big and small over big or whatever. Okay? So, all right, let's go solve this. Can I simplify this ratio? What did you divide by? What do y'all want to divide by? 4. All right, what's 12 divided by 4? What's 16 divided by 4? Do you see a pattern to get from 3 to 30? What did they do? times 10. So to get from 4 to x, I would times 10. What is 4 times 10? 40. Notice I would get the same answer here. Yes? I would simplify 3 over 4, multiply by 10, multiply by 10. It is the exact same problem, just set up slightly different looking. Are y'all with me? Could I have set this up differently? Could I have done green over green?
Yes.
Let's try it. Green over green. What would green over green be? 12 over 30. But if I do green over green, then I have to do pink over pink. But I don't get to pick what number goes on top. If I do green over green and I put the small one on top and the big one on bottom, what do you think I have to do over here for pink over pink? I must put small over big. Does that make sense? So what would the small pink be? 16. What would the big pink be? X. Let's go see if we get the exact same answer. Can I simplify 12 over 30?
Yes.
I could divide by 3. So 12 divided by 3 is 4, and 30 divided by 3 is 10. How would I get from 4 to 16? How would I get from 10 to x? What is 10 times 4? Do I get the same answer no matter how I set it up? Why? Because if you set up your proportions correctly, you'll always get the same answer. Make sense? Yes or no? Okay, now I don't expect you to do it a million different ways. You're going to pick whichever way works for you and solve it. Got it? Now let's look at a STAR test question from 2018. Before you read it, look at the pictures. What do you notice right away? They are not matching up. Like, it looks like they either twisted it or flipped it. Do y'all see what I'm saying? Here's the problem. I don't know what side goes with what. So I'm going to teach you how to figure it out, and it's very, very easy. It is going to have to tell you that they're similar, or you cannot assume. So read the problem. It says, quadrilateral KLMN is
Similar.
and then it says to quadrilateral WXYZ. And what you need to know is they just told you in these words what sides go with what sides.
Oh,
The way they wrote the letters matches up from here to here. So I want y'all to listen. KL came first. So it matches with the two that came first. And this is why the colors make so much sense. So I'm going to go highlight KL one color. And I'm going to highlight the corresponding side over here, the same color. And what side corresponds? WX. Are y'all good with this? What letters came next? I did KL. What else? LM. So I'm going to highlight LM, another color. And then I'm going to highlight the letters in the same spot over here. So what's in LM spot? XY. So I'm going to highlight them the same color. Do y'all see why we needed 4 colors? All right. Now I'm going to do the last 2 letters, which is MN. And I'm going to do the last 2 letters, which is YZ. Now, obviously, the other 2 sides correspond, but let me show y'all why. What comes first over here? And what comes last? So K to N. And then over here, what comes first? And what goes last? So W to Z belongs with K to N. So it looks like they rotated this, doesn't it?
yeah.
Now, let's read the question. It says, which statement about these quadrilaterals must be true? Did it ask you to solve anything?
No.
No. We know that they're similar. So before we read anything, let's talk about what we know about similar figures. We know their angles are the same. Give me a word for the same. Congruent. The same is? So their angles are congruent. We know their side lengths are not congruent. They are proportional. All right. F says KL over WX equals WZ over KN. What they just did, everybody look at my paper. They just did this. But instead of using numbers, they used what the sides are called. Can we take our highlighters and see if they set it up correctly?
Yes.
What color, now I'm going to ask y'all about my picture since all of ours are not the same. What color did I highlight KL?
Green.
So I am going to, y'all don't do green, y'all go do what color you highlighted KL. Okay, what color did I highlight WX?
Green.
Are y'all good? Now, what's wrong?
We have to do the other side.
Oh, but you're good, you get it, right? You just messed up. That's okay. You could also, so if you mess up, which your test will be on the computer, so your highlighter tools will be on the computer, so you can just literally hit back or erase it, right? Okay. Now here's the problem. They put green over green. So which one does KL come from? The big one or the small one? So this one's big. And WX comes from small. So that means whatever is over here, big has to be on top. All right, let's see. What color is WZ for me? Orange. What color is KN? Are my colors good? Green over green to orange over orange. Yes, but look at this. WZ came from the small shape and KN came from the big. Can I do that? No, that is not correct. Are y'all good with understanding why that is not a good proportion? All right, moving on to choice G. G says angle NKL. So everybody take your pencil and go to N and then trace it to K and to L and put a little line right here. That's the angle we're talking about. They said it is congruent to angle ZWX. Let's find ZWX and put a little line. Are those two angles in the same corresponding spot? Yes. How do I know that? Because they're between green and orange for me. If they're in the same spot, are the angles congruent? Yes. So I'm going to put a check mark. I think this is my answer. All right, let's go check choice H. I'm going to go highlight KL, what color I did it, which is, I did green. And YZ is blue for me. So I really don't even need to worry about big over small because they did two different colors. If this is correct, what has to be on top over here? Green, and what has to be on bottom? Blue. So let's see. LM, I did pink. Can I stop right there? Those aren't even related. This is absolutely no. If it's green over blue, it has to be green over blue. All right, last one. Angle NKL, everybody find NKL, we already did it, is congruent to angle XYZ.
No.
Not at all. First of all, this almost looks like a right angle, and that's like an acute angle, so absolutely not. So the answer was G. All right, last one. It says, don't answer it. It says, Mr. Ortiz used similar triangles to make a design. Which statement about the triangles must be true? I'm going to let you read it on your own, pick your answer, and then we're going to talk about it. Please do not say the answer out loud. All right, let's talk about it. Which statement about the triangles is true if they're similar? Part number A, letter A. Are similar triangles the same size
No.
and shape?
No.
How could we reword that to make that true? They're different sizes, but the same, so that's not true. All right, B says, similar triangles are the same size, but different shapes.
No.
If it's similar, can it be a different shape? No. All right, similar triangles have corresponding angles that are congruent. Are the angles that correspond the exact same?
Yes.
Yes, I'm going to put a check mark. Let's look at D. Similar triangles have corresponding sides that are congruent. Tell me how to fix that one.
They have to be similar because congruent is exactly.
Give me another word. They have corresponding sides that are proportional, so no. The answer is C. Okay, I'm going to pass out your assignment, but before we do, let's review what we just learned. Similar figures have to be the exact same shape, but their sides are proportional. Their angles are congruent. They're the exact same, and we can set up ratios to show their similarity, to show their proportions, and we can use those ratios to solve for missing sides. Yes? All right, on your assignment, the directions say each pair of figures is, they're telling you it's similar. They want you to find the missing side, and I want to see your ratios. I don't care if you can see the answer in your head. I promise you on the STAR test you won't be able to. You will have to set them up, so we need to practice, yes? The other thing I want y'all to do is think logically. If this is the smaller shape, then X must be smaller than... So think logically if you set it up correctly. So I would like to see that you highlighted, if you have your highlighters, the corresponding sides, and that you make your ratios. Got it? And then please box in your answer like X equals 5 or whatever. All right, get busy. When you finish, you may get on IXL.